of this, and thank you very much, Dan, for inviting us. Certainly great to be in Texas. And yeah, so I'm from XIRIS, and we're going to talk a little bit about our weld cameras and some of our technology around that. So the topic really is arc monitoring with real-time data. So that's kind of what sets us apart from just being able to view welding with a camera. Just give you a little bit of a background. So XIRIS weld cameras. So XIRIS has actually been in the machine vision business for some time. We started in 1989. The owner and still very active in the company is Cameron. He'd love to be here. Unfortunately, he's got other business to attend to, so you get me. But we've been around for a while, and actually what makes them interesting is they became really one of the best companies to go to for inspecting the print on things like CD discs and DVD discs. So up until sort of, the mid sort of, 2005-ish, they were actually doing quite good, and this was great business. Things changed. So they need to find something else. And then they started looking around and decided, well, you know what, welding's pretty cool. Don't know, they did. But anyway, that's what they did. And one of the first things they did is they started looking at how the welded tube market. So taking a flat piece of metal, and then normally with a high frequency welder or ERW process, welding that at high speed. And then it's a very tough environment. There's a lot of heat, a lot of smoke. It is nasty. Trying to measure anything there is tough. So they came up with a sensor to do that, which is actually right there on the right-hand side. It uses a laser, and then we measure the profile of the weld bead while it's still red hot. And we track and we sort of measure this bead, and we determine how good a weld this really is. And that's become very useful for a number of that type of application. And we sell a lot of that into the automotive industry, because everything is about, let's go to a thinner gauge, let's weld this thing a little bit faster, can we do something that's a little bit stronger? So the automotive industry's been pushing it. Aerospace, we also do sell into the oil and gas for the heavier section tubes. Just not long after that, they then looked at weld cameras for imaging welding. So those are these products down here. And we have a number of different ones. We've been evolving this. So these are kind of our Gen 3 products that will do a great job and we sell these today. They're great products for imaging welding and integrate with our software. And the new one we have is over here, which is, I have a couple of examples next door for anyone to see, is our new smaller camera, kind of using the same technology. There's a lot of other things happening under the hood. I'd say a lot of the company, more than 50% of it, is R&D focused. So we have a lot of software, we have a lot of electronics, we do our own mechanical designs, and we also have our own optics. So we do a lot of our own optical systems. So it's quite vertically integrated. A lot of the products we make, we sort of build them from the ground up. We control every aspect of it, which is quite interesting. Especially if you consider it's really not that big a company. Company today is about 35 people, most of which are based in Canada, where we develop, make, produce the product, test it, and we're now selling this globally. So we have some presence in Europe as well with our own office there. But honestly, our products get used all around the globe. And of course, always nice to be part of North America. So that's XIRIS. Now, what is the challenge really? So if you're gonna try and have a camera that's gonna image welding, there's different techniques for creating this image. You can sort of take different cameras and try and merge all those images together, some with short exposures, some with long exposures. You can try and take all of that information and put it together. So fortunately for us, I should say, welding is a very dynamic kind of process. You don't have time to take a number of different images and try and put them together. Yes, you can do other things like put filters in place, but you lose some information when you do that. So, our camera is really trying to solve that problem. And really what we want to do is we want to see what's going on in the very bright arc. We want to see what's happening in the melt pool. And then we also want to see what's happening a little bit around that area and be able to image that clearly. And that's the challenge we work with. And of course, we have cameras that do all of this. The exception of this would be sub-arc, as some of you might notice, where you don't really need a high dynamic range camera. You need a very robust camera. So just to iterate this point, so with a normal, if you go and buy any commercial camera, they'll tell you it's high dynamic range. It's using some other techniques. Typically, if you buy a good high dynamic range camera, normally it will have a dynamic range in the order of 60 dB, which is quite high. Unfortunately, if you point it to a weld in the bright arc, you will have to make a choice. You'll have to make a choice whether you want to see the background or you want to see the arc. You can't see both at the same time in one frame. And normally what ends up happening is the arc sort of blinds you to what's happening in the melt pool. Right? Our solution to this is we use a very specialized sensor in our cameras, along with some of the electronics to support it and to process this image. And what makes this different is it has an extremely high dynamic range. So in the order of 140 dB, which is around a 10 million to 1 contrast ratio. You can saturate it. It is quite tough to do it though. But what this allows you to do is you can see what's going on in the arc, you can see what's going on in the melt pool, and you can see what's going on in the surrounding area. So this is what makes our cameras different in terms of being able to do that effectively. So here's a little video. We're going to find out if it's going to work, and it does. So here, this is a MIG process, and this is kind of the result that we'd be looking for. So this is for like a nuclear vessel, where you want to make sure you see everything. You see how nicely the melt tool can tie into the sidewall. You can see all the wires coming into the melt pool. And you can have all this remotely. You don't need to be there looking at it physically all the time. So, of course, we've developed the camera. People are using our camera. We're able to, let's say, remove the operator from directly sitting behind the welding helmet, observing what's happening in the welding and then manually adjusting it. You can now, remove yourself from that and be, in a more safe environment, especially if you're trying to weld something that's, 10, 15, 20 foot up in the air. We can record that imaging. The next phase of this is how do we further automate this industry, right? So how do we take our images and how do we automate it? So in order to automate, we need to do a few things, right? We need to start off, of course, with the right camera. You need a camera that's going to give you a good image of what's going on so that you actually have something to measure and use to get that information. The other thing we think is important is that you need to have something that is versatile in configuration, meaning everyone's automation, everyone's piece of equipment is a little bit different, so you need something that can adapt, which is one of the reasons why, just as of last year in November, we came up with what we call our XVC 700, which is a smaller camera. It's a smaller, slimmer form factor, so it can fit into more places. And there's sort of a single cable. It's Ethernet based, so we run over GigE connections, GigE camera. With PoE means we power it and all the information comes through the one cable, which is Ethernet based, and goes to our camera. It's slim, it's small, it's light. And then we can also have different angles for this so that we can fit them into different pieces of automation. To put it together as a system, you can then pull it back into something like a fanless PC, because all of this information needs to come back to some sort of central computer, let's say, where we analyze the image, do the measurement, and then communicate that information out to the robot. So the other part of the magic that needs to happen is you need powerful machine vision software, and I'll show you a little bit of what that looks like in just a moment. And then, of course, the final part of this is how do we interface with the other pieces of automation, the robot, the welder, whatever it might be, to be able to do any corrective action, because that's ultimately where we're trying to go with this. So in terms of machine vision, so this is a rather long and complicated discussion, so I'll boil it down to a black box. There's sort of three things we really need to try and do. The first one is we need to require the image. So in this case, as Cooke explained, you need, if you're going to do it for welding, especially open arc welding, something with a very bright source, you need our kind of camera where you can get a nice, good, clean image coming through. Of course, you want to support, you want to be able to control how this camera operates. So you need some sort of interface from the computer in terms of controlling the exposure, the mode, how the camera is going to be triggered, all these kind of things. But really, a lot of the magic in terms of trying to take a measurement and do true machine vision in terms of trying to inspect a part or measure it or see what kind of variance there might be in it, there's a suite of machine vision tools. They're all software tools. There's probably about over 500 techniques that one could use and tools that one could use to try and analyze an image and extract certain features and determine certain aspects. I'll show you just a couple of those. And this kind of leads you down into machine learning and also into artificial intelligence, where you kind of start teaching the computer what things look like so that it can recognize it if it happens again. So it gets quite involved. And then the last one is, of course, once we've done all that magic, we've determined where, how big the melt pool is, we need to report that out. So there's some interfaces that we'll need to take care of to close the loop back with the automation. So just give you an example. So this is a pretty good one, a blob detector. So a blob detector pretty much is a tool that is quite commonly used, and we're trying to find all the pixels of a certain threshold. So it's a threshold-based solution. And in this case, this is a TIG torch here, and you're looking at a seam. And here's actually some of the image processing. This is actually a histogram that shows how many pixels are at what brightness effectively. And but here we have this blob, and it's kind of running around here, and we're trying to find out, where all these brightest pixels are, and it will show us where they are using a blob tool. So if I hit this, we of course can run this as part of our video, and we can adjust it. And you'll see there's some thresholding, so you can, depending what exactly you're looking for. It doesn't really care where they are in this case. But you can certainly control it in terms of where it's going to look and what it's going to do. And of course, the other interesting thing that happens once we've sort of segmented out all these pixels and we found this blob in this case, we can actually do a lot of reporting on this to tell you where the blob is, how big the blob is, where the center of gravity is, how long it is, all these kind of things. So all of this information now becomes available to us. So if you set it up right, you can get some good information back out of it. So that's always a good one. The next one that's also quite commonly done is called an edge detector. And again, there's many techniques of doing this. Pretty much what an edge detector will do for you, though, is it's going to run along. In this case, it's looking at this area of interest. So we're only interested in, let's say, the pixels in this area. It's going to run along here, and it's going to try and find edges. And edges, in this case, will mean where there's a great difference of contrast. So where bright pixels go dark, and trying to line up edges to where it thinks that's going to be. So same kind of image, and then you have similar kind of controls here where you can, you need to decide sort of what's an acceptable threshold to find an edge, and then there's all sorts of other tools in terms of trying to eliminate all the false edges, because if you have a very busy image, you may pick up on the wrong aspect. And again, what's important here is once you've located this and these tools work, you can get this information back out, and you can now say where these edges are. So this becomes another pretty useful tool. And again, there are many more other functions and transforms in terms of being able to process these images. So the software I was showing you, there's what we have is what we call Weld Studio. So Weld Studio works with all our open arc cameras. And we can kind of demonstrate it with that. What we also provide here is an SDK, which is a software development kit. so for people who are programmers. You can actually buy our software development kit, and you can use our tools to create your own applications. So people like OEMs, where you want to integrate our cameras into your control systems and really control that environment, you can use our SDK to create your own things. You don't just have to use our application to do it for you, because ours is kind of canned in this respect. So a lot of people who are OEMs and in research will use our SDKs, and increasingly more people in the additive space want to, they really look using our cameras to try and monitor and control their welding processes and integrate that very tightly. They'll use our SDK to try and bring in that information in real time, or as near as real time as possible. There's of course some delay in this. It's been available on the Windows base for a Windows operating system. What's new is, as of 2020, we've come out with a Linux version as well, so it's a cross-platform in that respect. But all these tools become available. We also have some applications, and this is where we can talk about, where XIRIS does offer other value in terms of we've created the tools, we've created the cameras, we've created the software that works with it. We also can create applications for specific applications, obviously. But in this case, we have a C monitor. So C monitor is used for tube mills, effectively. And here we are trying to do sort of seam finding and monitoring on that. In this case, we're looking at a laser welded tube. And you'll see here we have a blob detector running on the melt pool of the laser. We locate where that is. We also have the edge finding seam detection running below it. And then on the side here, we can graph it out. We can put thresholds on it. So this is the next one. This is a TIG tube mill. Here we have edge detectors looking for the tungsten, edge detectors looking for our seam. We're tracking the relative position of that. We can graph it. We can record it. We can have thresholds on this. So you can have warning, failure. We can report this out. This is a different one. This is quite good in terms of one of the challenges you have is you can really only do machine vision on great images. Like if you have a very grainy image or the image quality is not there, it gets incredibly tough. But we can get all sorts of information out of this. Distance between the seam, angle between the seam, many more things. And you'll see here on the lower side, we're talking about, these are kind of the results that this will be reporting kind of in real time. Another good thing about our system for doing this is it's actually measuring the position right at the arc in real time, meaning that there's no delay between when I measure it to when I try and come back. So we're picking up any deviation. The other thing is we can hide all these tools. You can actually have the operator still use this to see what's happening in the process, for using it for setup, all those type of things. This application is also, quite fully featured in terms of we have recipes. It's pretty much easy pretty easy, I'd say, for the operator to make any adjustments to the process or the setup of this tool. It has another tool here where it's actually kind of learning where the seam is, so that once you kind of start the process, you teach it where everything is, and then it will look for any deviation after that. So that was a spiral mill. This is actually quite interesting. This is a linear seamer with a plasma torch. Here we have blob tracking the plasma, but if you looked at this one, you'll see these are edge detectors trying to step over little tack welds, which is kind of tricky. But it is possible to manage all of that with machine vision. There's a lot of tools that one can use, but and this is kind of a micro TIG application where it's all pretty tiny. Not a great image in this case because it's monochrome. There's enough contrast we can actually resolve this image. So C monitor, I can kind of show you if you're interested after this to see, how it works and maybe some of the features of it. But it is a pretty good software for doing tracking. The other thing to point out, it's more than just software again. We have to look at it as a system. The system we have is, in this case, we're using our weld camera to get an image of the seam and the arc. We then bring that into, we normally have our own controller. So it's like an HMI, it's a PC in a box, on steroids. And from there, then, of course, we can have all the other interfaces, be it to second displays, be it to light towers for warning the operator as to what's going on when something's going off. We can then interface that into some sort of process monitoring system or automation. We also have sort of I/O for interfacing into PLCs or mills in case, let's say you want to spray or mark something that you thought was suspect or a defect. You can certainly interface with all of those things. And then we also do pretty much a low-level analog output because it's quite universal and easy to troubleshoot a lot of the times. And people, this is quite useful for people who want to close the loop. So, yeah, it's great. I saw the video. There's the TIG, there's the tip, there's the seam. We track it. But what if I want to move the torch so it always tracks the seam? Of course, the answer is currently our analog output. As whatever's needed, other interfaces are easy to add at this point. But that's pretty much what the system looks like. And thank you very much. Hopefully that was informative.